Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and good morning and good to all viewers and also attendees. First of all, thank you MPC Chemical Productivity Nexus for organizing the webinar today and inviting me to moderate. And also thank you to all attendees, all participants, for making time to attend the interesting webinar on topic that I consider is very good for the sharing. Yeah. By the way, my name is Riwayat, and I am the moderator for today. In order to accommodate for the majority of the audiences, this webinar will be moderated in bilingual, both English and Bahasa Malaysia. Today's webinar is one of many series organized by MPC, and the title or the subject of the talk today is Application for Effective and Efficient Manufacturing in Chemical Plant. Before we proceed further, let's clear a few housekeeping items so that the webinar can run smoothly. Yeah. In order to ensure smooth flow of the webinar, all participants will be put on mute. If you have any questions, there is a question section for you to utilize in the control panel. Yeah, depending whether in how you set it up. But your control panel is in your laptop or computer or your mobile, and it can be utilized to ask questions. And the questions can be asked both in Malay or in English. It depends on your preference and your comfort. Yeah. Depending on the situation, questions will be either posed to the speaker during the presentation, or we'll keep them until the end of the presentation. We'll try to answer all questions. If time doesn't permit for all the questions to be answered, the presenter may choose to respond them by email or WhatsApp later. Yeah. And to also inform you, in order for you to follow the presentation better, or you want to keep the handouts as reference, you can download them at the it is listed in the control panel. Yeah? And you can download the handouts, yeah, for your reference or your future keeping. Okay. Now with us today we are very fortunate, yeah, to have a very distinguished individual whom is very knowledgeable and also very intimate with MPC Chemical Productivity Nexus and the chemical industry, and he will share his own knowledge and also insights on the application of effective and efficient manufacturing in chemical plant. Allow me to introduce our speaker today, and his name is Dr. Adli Ferdin Ramli. Dr. Adli Ramli is a fellow of the Industrial Engineering Operation Management Society International, in short IEOM, based in Michigan, United States. He has been an auditor, assessor, trainer, consultant for operational excellence since 2001. His experience is in the automotive field, where he focuses on operational efficiency through eliminating waste using VSM and also lean technique. He has audited and assessed or rather assessed hundreds of organizations, including giant chemical plants such as Lotte Titan, Hitachi Chemical, and Industrial Resin Malaysia. Dr. Adli is a founder and director of EFR Certification, an international certification body. He conducts a variety of high-impact training and workshops in the area of workplace improvement, waste reduction and variation, problem-solving techniques, and stuff like that. Because of his extensive exposure in various management systems, he actively involved in the areas of auditing, evaluating, consulting, and training in business excellence, operational excellence, lean management system, quality such as ISO 9001 and IATF 16949. and the environmental system ISO 14001, OS, occupational health ISO 45001, business continuity, ISO 22301, to all level of organization, including SME and also MNC. Okay, that's a little bit about Dr. Adli. So without further ado, please, I would like to invite Dr. Adli to share with us the topic on application for effective and efficient manufacturing in chemical plant. Dr. Adli, please share your insight with us. Proceed, please.
Okay, thank you, IR Riwayat. It's a pleasure to meet you, NPC organizer Cik Mazwan, and also MPC Nexus team, for example like Shukri. So thank you very much. It's a pleasure for me. Okay, and I'm also fortunate to have my Sifu also, IR Riwayat, in this lead. So he's very experienced as well. We work together on one project last time in Meru, but not top glove lah.
Luckily, but it was before. It's okay.
Before COVID. All right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. First of all, thank you to all the participants that joined this webinar. And actually, my topic here is about the effective and efficient manufacturing chemical plant. Right. Before we start, actually, there is mainly about three topics I like to share. Okay, which is first one. Normally, we talk about efficiency. Okay, but there is an issue in the efficiency measurement, especially in the chemical plant. Okay, for example, the issue is the measurement actually not reflect, okay, how is the performance of the chemical plant. Okay, for example, I have one of my client in 2005, 2006. Okay, it's named Industrial Resin Malaysia. It's quite big plant. Okay, it's doing very well, but by end of 2010 or 2011, okay, the plant shut down. Closed down, not shut down. It's closed down. Okay, it surprised me because it's so huge. You have so many clients, but at the end, you have to cease operation because it's in loss. Okay, what's wrong with that? Okay, so I like to share some of the, I say, not accurate measurement that been used by that organization until at the end, actually they are not efficient in their operation. So that is the first topic. Okay, is on the efficiency measurement. Okay, on the second topic that I like to share within this short period of time is less than 1 hour. Is talking about value-added activity. This is actually for those who are familiar with Lean. Maybe you are quite well versed in this subject. Right? For example, 7 kinds of waste. Okay, what is value-added, what is non-value-added, and so on. Okay, but in this webinar, basically I will share. In terms of a common value-added activities in the chemical plant, and on the third topic, what is a common waste in the chemical plant? Right. So, of course, maybe some of the participant here is from big chemical industry, right? Giant multinational. Okay, maybe some of the participant here, maybe just a small chemical plant. Maybe just doing a simple compounding or mixing of the chemical, making some glue. Okay, so this is the common chemical industry that that's been listed under European NIST code, and it's under code C19. Okay, basically it's C19 is talking about petroleum. That's why it put other closely related. C20 is actually the chemical industry. Okay, and we have C21, 22, 23, which is closely talk about paint, ink, sealant, adhesive. Okay, and in fact, in chemical industry also, we can consider food processing. Okay, process is almost the same like chemical industry. Okay, for example, in the food processing, normally we have blending, we have mixing, we have cooking. Okay, cooking sometime in chemical industry we didn't call it cooking, we call it chemical reaction process using reactor. Okay, so actually food processing is almost the same. Okay, in chemical industry. Okay, but all this industry have almost a common issue or a common problem. Okay, which is they measure in terms of effective, which is the definition of effective is a successful in producing a desired or intended result. Okay, common in chemical industry. When I audit this organization, what they did is when they measure in terms of efficiency, okay, actually they are measure based on their daily output or daily capacity. Okay, example, this chemical plant A, maybe they can produce let's say 10 ton of product, 10 ton of product. Okay, and then they measure their production output. They only produce maybe 7 ton per day. Okay, and then they measure. Okay, their efficiency is 70%. Okay, it's 70%. Okay, what's wrong with that? Right, first of all, when we look on the definition of efficiency, okay, we can look under Wikipedia type of the definition. Okay, this one I take from Oxford Dictionary. All right, it said that efficiency is producing satisfactory result, mean effective. Okay, it's supposed to produce 10 ton. Okay, it's produce 10 ton per day. Okay, but without wasting time or energy. In other words, it's the term optimum. It means they didn't waste the resources. All right. Generally, efficiency related to productivity. This one I share about productivity in the micro level, not a macroeconomic. Macroeconomic productivity is defined by the GDP growth over time. That's macro. Okay, but on the micro side, okay, basically productivity or efficiency actually is measured in terms of output, okay, divided by input. Okay, so when we compare, the first common measurement that been done by the chemical plant, they say they measure the efficiency. Their efficiency is 70%. Okay, so 70% out from their productions means from the example I give just now is 7 ton of product. Okay, but the question is that 7 ton is going to be stored and keep as the stock, or is it going to be sell to the customer and we can get the profit from it? Okay, so if we're producing, let's say even we're producing a more efficient plant, we have like instead of 10 ton, we produce 11 ton or 12 ton. Is it that value is converted into sales? Okay, or is it going just to keep in the warehouse? Okay, so one of the case study that I shared, the company has been closed down, cease operation. Okay, they try to meet their efficiency. Their efficiency is about 80-90%. They can produce to their capacity. But the question here is, can they convert into sales? Okay, so let's say they produce 10 ton. Okay, so are they selling that 10 tons? or they're selling 10 tons, but there is a rejection about 2 tons have to be returned by the customer. So actually they are producing 10 tons, they're selling 10 tons, but the problem is there is a return from the customer. The problem is maybe some of the material is used excessive. So at the end, actually they didn't make a profit. All right. And then after it's so long, maybe after 10 years, they didn't realize it. Okay, I produce, my plant is efficient, but why I didn't make a profit? So this measurement have to be corrected. Okay, instead of measuring the efficiency in terms of plant utilization, so the best is by looking on output divide by input. Okay, sales divide by the input, the cost of material, operational cost, and so on. All right. So the result in my previous organization when I work, I use this productivity measurement. I paste in the company bulletin boards. We paste in the canteen to show that this month how much is our productivity, how much is our plant efficiency. Okay, so if the result is more than one, if the result is more than one, what does it mean? Riwayat, let's say it's more than one. Means let's say the sales is 10 million. Okay, and then your input cost, everything is only maybe 7 million. Okay, so you get a result is more than one. All right, so it's maybe if I put 7.5, it's much more easier. Okay, this one will be 1.5. Okay, so what is the meaning if 1.5? Even though we didn't show the value, we didn't show the million here, the RM here, but when we put in the board, yes, our company have productivity 1.5. So it means that our company is making profit, right, on that month. Okay, because this 7.5 million is the cost of direct material, is the electricity cost, the labor cost, the consumables is only 7.5. So in other words, we are making 2.5 million profit. So 1.5 it means that we are making profit. Okay, but let's say the productivity is show that we only have one. What is the meaning of one? Okay, so one means we are break even. And then if we get less than one, maybe we get 0.8. Okay, so the people in the plant normally going to understand that the company this month making some losses. Okay, but at least they are prepared for next month so that they're not going to make any losses. So everybody will work together to achieve this measurement. Right, so at least it's visible because my riwayat, some company they try to hide their figure. They say the company making loss, so no bonus. Every year loss, no bonus. But this one is more transparent. Okay, at least we show every month. Okay, if you got 1.1 or 1.2, at least the staff is motivated to know that actually their company is making profits. If they're not making profit, at least they know how to work together to achieve at least more than one for their productivity or efficiency. Okay, so this is the one part. Yeah. Okay.
Yeah, and at the same time, just to make sure that whatever we produce and send to the customer, which is the output, which is the sales, they are not written back as written RMA lah. You know, there's no written parts or rejected over there lah. I mean, in order to make sure that the profitability is maintained, right?
Yes. Okay, because once you have to return, the cost will be under input already. You have to do a credit note. That will be under operational cost. We have to send people for rework, and the transportation cost will be increasing. Automatically it will be input, and then if we show maybe not that month, maybe on the next month, and that's the company is making loss actually because of their
Correct.
their sales is high, but they have problem in their operational costs.
Yeah.
Okay,
Okay.
so this is the first part that make the chemical industry not productive because they are measuring something that is not reflecting their performance. Okay, so to reflect their performance, it's important that they have to measure the efficiency in terms of monetary measurement. Okay, go by sales. You can do monthly or you can do quarterly. My previous company that I work, we monitor it monthly. Okay, we show to the staff. Okay, even they will get some special bonus on that month if we achieve more than 1.2. Okay, so everybody will get that. So if we lost, at least everybody try to find out why that month this is not profitable. Okay, so that's first part. And then yes,
monthly is better, right, Dr. Adli, because you can react faster. I mean, you get the result faster, you can react faster, so that you don't have to wait until the end of quarter to react. I think your company has been doing it well, so do it on monthly basis rather than weekly. Yeah.
okay, that's always the best to have more real-time data. If more real-time, the faster we can react. So it's correct.
Correct.
Thank you. All right. So nowadays, example, when I visit some of the chemical plant, okay, so they are now trying to hold some stock in this scenario because the raw material price is actually low right now. Okay, the crude oil is low. Okay, so they tell that okay, they don't have enough capacity and so on. There's maybe some speculation on that. Okay, but most of the resin company now they say they have a problem to get the stock right now. Okay, but if we look at the actual scenario, okay, actually the crude oil is cheap. Right? This time they should be produced more. Okay, but maybe they want to hold some of the stock so that they can maintain the price. Okay, in order that they're not going to make a loss. But that is other strategy not cover under this webinar. Okay, but anyway, when we want to improve our efficiency, okay, so our traditional method, okay, our traditional method is basically we think about increasing the price, then we can increase the profit. Okay, but actually one of the things that we have to balance off as well, okay, instead of increasing the price, okay, we should look on our costs in operation to make it more efficient. Okay, to look how you spend on your overheads, how you spend on materials, okay, and so on. Okay, so that you will be always ahead of your competitors. Maybe some competitors, when they have no choice, they increase the price, but you can maintain the price. Then you will become what we call the preferred supplier to them. All right, so how to make this efficiency at maximum? Okay, so there is a important factor that's normally discussed under the lean manufacturing, which is we talk about value added and non value added. All right. Okay, so for those who are quite good in terms of value added and non-value added in lean, okay, so basically we're talking about value definition first of all, okay, which is value can only be defined by customer in terms of whether they want to buy or not. Okay, this is where just now I mentioned about this traditional thinking. We want to make more profit, okay, by increasing the price. Okay, it is not that healthy because we create inflations, okay, we create uncertainty, okay, but let's say suddenly your customer find another competitors with the same good quality, with the same good services, okay, but at a lower price, maybe they will go to the next competitor. So the best, if we can maintain the price, but we try to minimize our cost through a lean thinking concept, right? So this lean thinking concept is actually the concept that been introduced by Toyota, okay, in which they define the value, okay, in term for manufacturing. This is a special for manufacturing, okay. They define in manufacturing anything or the activity or the process that change the shape or character of the product, that is considered as value, okay. But if it didn't change the physical or the product, later I will give some example. Okay, example in chemical industry, okay, we have a process. We have process called example charging, charging, okay, or or some process we call it mixing. Charging is actually is feeding, okay, the feeding chemical A with chemical B, okay, so there's called charging, okay, and then mixing, okay, we mix chemical A, chemical B, and maybe in one of the mixing tank, okay, and then we have the common process we call a chemical reaction, okay. Chemical reaction is basically in most of chemical industry is applying the pressure and then applying the temperature, and then it may take 1 hour, 2 hours before it can react well, okay, and then it come up with the product, okay. And then we have a blending process, we have pumping, packing process, and so on, right? So the question is, which one is considered as changing product, physical of the product? One of the important point here, okay, we talk about manufacturing and not trading, because it's under chemical access. Most of the company is a manufacturing company, okay. Means that in manufacturing activity that is change the raw material, okay. Example, you put one chemical A, okay, and then you plus with chemical B, okay, and then you do some chemical reaction in the reactor, so you become product C. Okay, so inside here you apply the temperature, you apply the pressure, you do some stirring using agitator and so on, then you can sell this product C. Okay, so this is considered as the manufacturing process. Okay, other than that, okay, example, when we want to feed this chemical A into the reactor. Okay, so this actually is a process that didn't change the physical of the product, okay, or the characteristic of the product. Okay, so this process normally we going to identify that as the move activity, movement activity, or move process. Example, another move process is from warehouse, you bring into the front of the reactor, and then you charge to the manufacturing process. Okay, that is move process. And quite fortunate, because we only have 1 hour. Okay, we're going to have another session in the afternoon. Maji, Riwayat. Okay, we have movement discussion. Okay, how to minimize this okay, at 3 o'clock. For those who have the time, okay, at 3 p.m. I will discuss more about how to minimize this non-value-added activity of movement processing chemical plant. Okay, so move from warehouse, move from plant A to plant B and so on, that is considered is a non-value-added. Okay, and then there is a storage process. Okay, so this storage process as well is basically not change. Actually, it didn't change the physical. So this maybe there is a warehouse here. Okay, so this is raw material. We have tank farm. Okay, we have tank farm here. Okay, and then we keep and then we pump the chemical B okay to the process. This is all considered as non-value added activity. Okay, so that if we want to become more efficient, what we need to do, if we can eliminate this, if we can eliminate this, it will be nice. Or if we can reduce it, if we cannot eliminate it, that will make your organization more efficient. Your chemical plant will be more efficient. All right, and then you have so many storage in here. You produce 10 ton, but actually customer only buy 1 ton. You keep the stock. Actually, that is also considered as a non-value added activity. So basically, in this example, I show you there is 2 examples non-value added activity. One is move, one is a storage. Of course, there is more. Later we're going to talk about 7 kind of waste. Okay, which is this will also improve your chemical plant activities. Okay, so let's do a simple exercise here. Okay, so basically we have some example. Okay, category whether is we want to identify whether this activity is value added or non-value added. Okay, because non-value added will make your operation less efficient. You need more time, more people, and more money to manage them. Okay, if you can reduce, we can eliminate, then we can become more efficient. Okay, so let's start with the first one. Okay, number 1. First one, we have a chemical in liquid, or maybe it's in a powder base, or maybe in a solid state also can. Okay, we have to pump out from tank farm, maybe from the tank, okay, or maybe it's from drum to the process. Okay, like I mentioned, okay, this is considered as move process. Okay, it didn't change the physical. This is considered as non-value added. Okay, so this is non-value added, NVA, NVA. Okay. Pump in and out. Okay, so sometimes the process is we pump the raw material to the reactor. Okay, sometimes we use feeding or the charging. In one of the company that I observe, I audit them last week. Okay, actually they use manual charging. Manual charging means they buy the raw material in 25 kilo bag. They cut the bag, okay, and then they put into the reactor. Okay, reactor is something, if you're cooking, is something like, we call it pot ataupun periuk lah, periuk nak masak. Okay, that's considered a cooking process. Okay, or reaction process. So they are using a manual. So you can imagine, okay, there is 10 ton of production. So how many bag? The bag is only 25 kilo. Okay, so 1 ton is about 40 bag. 10 ton is about 400 bag, and they have to do it manually. Okay, so if this charging we can minimize, we can use automation. Maybe we have IR 4.0. We just press a button, charge. Okay, 10 ton. That will be more efficient instead of manual charging. So this charging is non-value added. If we can minimize, okay, if we can improve, that will be massive opportunity in the chemical plant. Okay, so how about transfer and moving? Okay, transfer and moving is another NVA. Okay, so we have to move the parts and so on. So this non-value added. Okay, and then we have to count the bag. We have to count the drum. Okay, the counting also not change the physical is considered as non-value added. Okay, so this is an example of 4 common activity in chemical plant that I observed that they have this non-value added activity. Okay, others plating is actually before that the part is not shining. We do a plating process, become shining. We consider as value added. All right, mixing process, of course, in cooking, in chemical reaction, we have to mix. We have to do blending process. Okay, that is value added. Okay, heat treatments. Okay, of course, we consider that as value added. Okay, so this is on the second section. Basically, discuss about value added and non-value added in the chemical industry. Okay, so Engineer Riwayat, anything you like to add in?
Yeah, good that you mentioned about the process where sometimes the process is non-value add. And then what you do is, since you have to do that process, even though that is, it's non-value add, you have to do that process. And sometimes people call it like business value add or necessary non-value add or business, or other people call it value enabler and stuff like that. And and then since we cannot get rid of that process, and the process is in actual fact is non-value add, and sometimes you want to spend less resource there, and that's why you just mentioned about employing, or rather adopting the industry 4.0, just to minimize the time that we spend, the resource that we spend there, and all that. I think some people are confused. If the process is not value add, why do you need to what do you call spend more money on it, since it's non value add? But sometimes you cannot run from it. Is the requirement for the organization. You still need to move stuff around, because you cannot move by itself. But how do you move it around? By having less resource, like that, using the technology, right? I just want to echo what you said just now. So
okay, so takkan nak gunakan jin kan pakai jin nak angkat barang kan.
He move by himself, huh? Right, yeah, continue. Okay, thanks for the explanation.
Thanks for the input. Okay, so like Engineer Riwayat say, okay, basically when we talk about charging, we still have to charge. Okay, of course, if we can use some automation. Okay, when we say value added, normally we can divide into two. One is avoidable, which is we should eliminate it. One is non-avoidable. We still have to feed into the master batch and base to the reactor. So we have to feed all the ingredient into the process. So the feeding, even though it's non-value added, but we consider it unavoidable. So if we can minimize it, we can automation it, it will make your plant more efficient. All right, of course, there is some issue, okay, especially when we want to eliminate all this waste in the process. Okay, so we have to identify, first of all, a common issue based on these 7 kind of the waste. This is a sharing session, and maybe in the 20 minutes, I just going to share about waiting, overproduction, rework, overprocessing, and inventory. Okay, but I will skip on the motion and transport, because this one will be detailed at 3 p.m. later. I will further discuss about this. Okay, this 7 kind of waste is, if you first time you can Google out what is that, where it come from. If you are quite familiar, okay, this is from the Toyota, and then we have the additional, maybe the 8 ways, 9 ways, whatever. Okay, but this is the basic one. All right. So in short, basically I use a short form of worm pit. Okay, lubang cacing. Lubang cacing because nak memorize is much more easier. Worm, W, waiting, overproduction, rework, motion. Okay, P is actually for over processing, but I cannot put O, dia tak jadi lubang nanti, tak jadi pit. Alright, and then inventory and also transport. Okay, so in chemical plant, basically.
Yes, Dr.
Yes.
Adli, just to input also. You go to the previous slide kalau boleh.
Okay, can.
Good that you have this. This is yang 7 ways tu kadang-kadang orang guna worm pit, WORMPIT. Yang setengah guna teamwood, TIMWOOD. Yang setengah guna cow team. Banyak dia punya akronim. Very is how apa ni creative people are when they want to use acronym. Tapi yang 8 ways tu pun bagus juga, dia guna downtime, DOWN TIME, ya. Dia banyak akronim untuk ways ni, ya. Worm pit is one, cow team is one, the other one teamwood, because maybe last time Tiger Wood was very famous. They use his brother teamwood as the acronym, ya. And now people use the 8 ways the downtime. Good. Just for the participant.
There's many acronym. So, but today I use worm pit instead of downtime and so on. Okay. Just want to go to the basic one.
Correct.
Okay, so about the issue common in chemical plant. Okay, most of the plant, okay, they have issue in terms of how economically that they should design their reactor. Okay, and those big company normally going to make a very big reactor. Okay, why they say? Because the chemical reaction process may take 6 hours. Some reaction, for example, on the refinery, may take about 12 hours. So they say they have to make a big reactor. Okay, so that they are more efficient. Okay, but after I talk with some of the product engineers, those chemists, okay, actually before they make or before they decide to design the big reactor like this, okay, actually they are producing with the small scale, okay, for their R&D. So normally in R&D, they just use a small scale. Okay, and then they will do a study to do the upscale. Upscale, for example, when they do their R&D, they may use a few gram or few kilogram only to see their chemical reaction. Okay, so but to make a project mega, instead of the upscale to the medium scale first, okay, and then suddenly they straight upscale to the big one. Okay, but when there's a problem, of course, when I talk to the process engineer, some product engineer, they say, okay, because it takes 6 to 12 hours reaction time, so they say better have the big one and then they can produce. Okay, I ask them, okay, instead of having a big one, for example, this is 10 ton. Okay, is it okay to have a smaller one and maybe have 2 ton, 2 ton times 5? Okay, so is it feasible or not? If I ask them, okay, they say can, no problem. Okay, but why go for big instead of having small? They say big is more efficient. Produce straight away 10 ton. But small, they say they have more charging activity, more people to handle, and so on. So they say this is not efficient. Okay, but I question back to them. Let's say if this big reactor have some technical issue or downtime or the problems. Okay, so can you produce that 10 ton or not? Let's say it takes 7 days, so you lost 7-day production. Because of you want to chase for more efficient. Okay, but let's say if you have a problem, okay, then instead of become more efficient, it become worse. You cannot sell a product. There will be backlog of orders and so on. But I told them, if you have these 5, let's say one down, you still can run another 4. Okay, if it don't have any problem when you do the scale up activity, okay, maybe you just buy 1 or 2 reactor first. The first, second reactor is okay. Then we can have the third one with the improved version, with more with IR 4.0, and then we can have the 4th reactor, 5th reactor with more technology. Okay, so I asked them, right, what do you think about that? They say, oh yeah, that's better, but our top management prefer this big one, okay, instead of having this small one, because they say it's maybe not efficient. Okay, but anyway, there is some challenge that normally I'm as the lean practitioner try to convince them. Okay, okay, buy a smaller version because it's better. Okay, let's say you charge 10 tons, suddenly you have quality issue, then you have to scrap 10 tons. If you have these 5, maybe one of the reactor have a problem, but you still have 4 that is good. Okay, so you're going to have less waste. Okay, in your production. All right. So, but they say, we already have big one. We don't want to invest a small one. How? Okay, I say it's okay. Okay, continue that. But I recommend that your organization should implement TPM so that okay we're going to have less downtime with total productive maintenance. And we're going to meet again, Ji. We're going to meet on 30th, okay, 30. Okay, so we will discuss about this TPM. TPM, especially those chemical plant yang besar-besar ni, those big one. Okay, they can't afford the downtime. So TPM is one of the important tools in the chemical plant to ensure that it keep running, because you have no choice. You already have a big one. So that's why in here I put small versus big. Tapi jangan fikir lain pula. Jangan fikir bukan-bukan dia jadi lain pula. Small versus big. Alright, so big. So actually they have benefit, but in lean practitioner, lean manufacturing, we try to have a smaller one, okay, but with quantity, more quantity to produce the output. Okay, but I also asked the R&D people, okay, is the time going to be long? Okay, the time going to be long. For example, like 10-ton reactor, they say it takes 6 hours or to 10 hours the reaction time. So if you use small one, how long it takes? Actually, theoretically, they say if smaller one, we can put the pressure faster. Right? We can increase the pressure faster. We can increase the temperature faster. We can have a smaller agitator, kipas yang kat bawah tu or kat atas. Okay, so we can have a smaller one. We can run at the higher RPM. The reaction should be much more faster. Okay, the reaction instead of maybe 6 hours, if using a smaller scale, actually it can half of it, because the temperature can be raised faster because it's small. Pressure, you can raise it up faster. The speed of the agitator you can put is faster. Okay, so the reaction time will be faster, and then you can produce more. Instead of having this big one, okay, but it produce longer result. Okay, so this is some issue in the chemical industry. Okay, whether should we go for big, go for small? If you ask me, under the operational management, industry engineer, I prefer it to be small first. Okay, if it already known, is reliable, and no problems, then we can consider the big reaction tank or mixing tank and so on. Okay, so that's one example or one issue. All right, so
Small will
riwayat
be
ini,
more flexible, yeah.
yes,
Small will be more flexible because yeah, the change in volume is the volume is not always stable. It can be small, it can be big, and when it's down, then you can reduce accordingly. So I think small. I have to agree with you. Small is better in the sense that it's more flexible and you can manage better.
Okay, so we need more people like you, okay, to convince the top management. Okay, go for small first, and then let's say it's already stable, then we want to go bigger. Your market is stable already, then you can go. Okay, but this is the most difficult part when I try to consult the organization whether to go small. All right, so next one. Actually, the next one, when we talk about the waste, okay, of course, when we have the big, we create more waste. Some people call this big one, overproduction is king of the waste, raja segala pembaziran. Okay, dan pembaziran amalan syaitan. Alright. Okay, so this is the greatest waste. It is create other waste, because you create a motion waste because we have to handle more. Okay, we need to have more big warehouse to pile our stock, filling storage. Okay, which is need a more complicated IT system to manage the ERP system and so on. So it become more works, and it makes your operation cost is higher. When operation cost is higher, then your efficiency is going down. Okay, so if you can manage this, it will be better for your organization. Okay, so second type of waste, I just going to go through this one quickly. Okay, waiting is happen, especially when you have the bigger reactor just now. Okay, the reaction time is 6 hours, 10 hours. Okay, so the operator in the control room have to wait for the process, and the people that doing charging have to wait. Okay, and of course, another reason for waiting is because of machine down. Machine down is one, okay, which is going to discuss in PM. Okay, and then we have problem of no order as well. When there is no order, okay, so no work, and then we have waiting issue, right? And I move to rework. Okay, rework or repair. Okay, sometime in the chemical plant, rework is quite common. We show back to this slide. Okay, when in the reaction process, for example, under this part, reaction process. Okay, so basically, there is if there is a big plant, okay, the problem in here, okay, there is some chemical that not react well, so we have to reprocess back. Okay, so when you do the reprocess back, this is additional work. We supposed to produce 10 ton because of it's not that good enough. Okay, it's only produced 8 ton, so another 2 ton, maybe 1 ton is go back to the process. Okay, but anyway, it's a closed loop. It's no waste. Okay, but the problem is under this part, byproduct and product waste. Okay, so byproduct, basically for you to sell at the premium price. Okay, some of the product maybe you have to go to the special process. We call it rework. Okay, some maybe call it blending, reblend, rework, and then reblend. Okay, rework, reblend, and so on. Okay, so actually you should produce 10 ton here, okay, but you have to rework 2 ton. Means it's over processing. Means you have to do more process. It's more waste, less efficient. right? So this is happen when you have a bigger reactor. If you have a smaller reactor, the process is almost 99% yield, is produced 99% good product, only less than 1% that maybe go to byproduct and waste. Okay, that's can improve your efficiency. Okay, of course, some of not good will become waste. So this is something that will make your chemical plant less efficient. Okay, so we have another about 5 minutes, okay, for this session. I think most of you already hungry for lunch, okay, but listening is okay lah. You can eat something while listening, betul lah. Yeah. Alright. So.
Itu sebab tu kadang-kadang tutup kamera minum dulu.
Oh, tutup kamera tu maksudnya minum lah tu. Okay. New trick. Okay. So next time I shoot off the camera before I drink. Okay, so rework and then over processing. Okay, it's the same. I mean, doing more work. Right? If you can produce 99% yield, okay, it's better than you produce 80%. Okay, and then you have to do another process. Okay, this process sometimes called purifying, process of sorting, process of milling because the size is not correct. You have to do sieving. That is additional. But if you produce it right at the first time, so basically you don't need to have this additional process. So that is make the organization not efficient. Okay, so from the observation that I make, the company that closed, one of the company is they have too much rework actually. They have too much by process. Okay, beside their reactor, they have another smaller reactor to do the rework. They have to do rebatching activity. Okay, in which I ask, okay, why you need this process? Because they have a quality problem. Okay, why? Because our reactor is too big. So at the end, they think their reactor is efficient, but actually they're not making money. They are lost. Okay, so that's why the company has to cease the operation. Okay, over processing is one of it. Inventory, of course, when you have big plant, big operations, so you have more stock. You have to make it flow, sell to the customer, so that your productivity is going up. Okay, and your issue, basically, final one, before I pass to IR Riwayat. Okay, so actually, why we make it our reactor big, why we make more, okay, because you are trying to hide your problem. Okay, actually the problem is maybe you have problem on breakdown. So you have to produce more to meet the customer demand. So this is your inventory level. So you have to keep more stock so that we can keep supply. When we have the bigger chemical plant, again, normally the setup will take up long. Okay, this is another area that IR 4.0 SMED can help to reduce it, because when you reduce all this problem, reduce scheduling problem, you reduce setup problem, you reduce supply, all you cut into half. Okay, basically you can be more productive. Okay, and you can reduce your inventory level. Okay, and then make your operation more efficient. Right, so reduce this, find where is the problem. Okay, of course we have webinar this afternoon on the movement waste. Okay, so we share some of the case study that we improve a simple pipeline that reduce the movement of the forklift, movement of trucks. That's will be on this afternoon. Okay, and then we have the TPM. We're going to talk a little bit more about the breakdown, to be more efficient, how to reduce that, to reduce the long setup using the TPM, to reduce the skill shortage. Some technological machine capacity is all under TPM. We're going to meet on 30th. We share some of my observation and assessment on TPM. Of course, on the final, on 2nd of December, I will share about the process readiness to implement IR 4.0. Okay, so yeah, please spare your time, okay, for that webinar. Okay, this afternoon on 30th, another webinar, and on the 2nd of December. Okay, so there is a massive opportunity, okay, to improve the manufacturing efficiency. Of course, this 1 hour just to have some insight, okay, how to apply some of the concept, the lean concept, the efficient concept in the chemical plant. And before I give back to Engineer Riwayat, okay, so basically, okay, so this is just a concept, okay, and then more study, more works need to be done to make your operation more efficient, make more profit, and give back to the society, give back to your workers, okay, and become more productive. Okay, so that's my final slide. So, Ji, I pass back to you.
Okay,
Question, you
great.
can.
Yeah, all right. It has been great. It has been very insightful sharing from you, Dr. Lee. And you have covered quite a bit of ground. Yeah. And actually, our next agenda for this webinar is to answer questions. I look at the question panel here. There's no question. Looks like you have been, sharing your thought very clearly. So I have a few questions, but I think we can still use other what do you call other webinars to go through that. I know that we are right now between the participants and also lunch. And so time is already up now. It's 12, almost 12:50. We're supposed to end at 12:45. And actually, I wanted to ask you also your parting words, your parting remarks. But I saw this in your last slide: elimination or reduce. I think waste is everywhere. I think that's good. Always enough remark for the participants to take back. And what we need to do is just to make sure that we either eliminate waste, or if we cannot eliminate altogether, we need to reduce them to a bearable level. So that's good. And since no question, I said, and I think the last slide would be your parting remark. I would like to thank Dr. Eddie, our speaker today, for this webinar on his valuable knowledge that he shared with us. Thank you, MPC, for the effort, and being a great organizer. And thank you all the individuals who have made this webinar possible. And at any rate, stay safe, stay at home if you don't have to go out, stay healthy. However, let's continue to be productive by learning new things and to continue to sharpen our mind with online knowledge and sharing such as this one. Yeah. So let's adapt ourselves to this new normal. Thank you very much. Wabillahi taufiq. Ya, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you. Assalamualaikum.
Waalaikumsalam warahmatullahi. Okay, terima kasih. Okay,
Ya,
insyaAllah jumpa petang pukul 3.
Jumpa lagi insyaAllah ya. Jumpa lagi insyaAllah.